Okay, we are presented with another situation. So before we move any further, let's write this out a bit more explicitly. So in the past two examples, I presented you situations in which the base was pretty assumable, it had a negative charge on it. But in this situation, we need to decide what is our base and what is our acid. And when I'm looking at this, I see two possibilities for our base. I see this oxygen and I see this nitrogen. But what is more basic? Or I guess what is our base and what is our acid? And if we recognize from our functional groups, this is actually called a carboxylic acid. So because the name suggests, I'm going to run through this problem that this is the acid. And what we'll find out is that amines are basic, and nitrogen is typically a more basic element than oxygen. So this is actually going to be our base in question. So when I attack, I know that oxygen is more electronegative than H, so the electron bond snaps onto oxygen, and I end up with this situation in which I have charges. And you're like, well, what the hell? Why, we had a stable neutral situation before, and now we have a charged situation. So which way will it go? And we have to think about our factors again. So when we're thinking about what we got going on over here, we have electronegativity, size, resonance, hybridization, and induction. So when we're comparing, remember, we have to think which acid, or I guess which base, is more stable. Is this amine more stable, or is this carboxylate? And what do we have going for it? Well, we have a nitrogen, which is neutral. So it's neutral. I'll give it, that's pretty good. Nitrogen's pretty electronegative, it's not incredibly electronegative, but nitrogen's electronegative and it's neutral, which are two factors I think are supporting our left side. But the right, we have a negative charge on O, which is extremely electronegative. And what do we also recognize is that we have a resonance form in which now we have a resonance form in which we have resonance on 2 times O. So resonance distributes this negative charge not on 1, but on 2 oxygens. So while the left side is neutral, the right side, we have a negative charge on 2 extremely electronegative atoms linked through resonance. And because of that, the argument will dictate that equilibrium moves to the right side. And that's because we have a situation in which the resulting conjugate base is so stable. Amines are basic by nature. Carboxylic acids are very acidic. They have a pKa of about 5. Ammonium has a pKa of about 10. So it lies to the side of the higher pKa. This is goofy because you think neutral on the left, charged on the right, but because of this incredible result of having a charge displaced onto 2 oxygens, it's incredibly stable. Also, we know that nitrogen isn't so mad if he has to have a positive charge because he's one of those guys that can get negative and positive. And what we know is ammonium is 10, carboxylic acid's pKa is 5. But the big play here is resonance as well as electronegativity. So resonance and electronegativity coupled together outweigh the neutrality on the left side.